A corridor of water, dozens of miles wide, hundreds of ships, power for entire continents. It may sound like an abstract image, almost a movie scene, but it's not a metaphor. This corridor exists. It's real. It shows up on any world map. And while you watch this video, it's carrying the energy that keeps factories running, planes taking off, ports operating, and entire cities lit. This place has a name, the Strait of Hormuz. If you look at a map of the Middle East, you'll see what looks like the planet's elbow. On one side is the Persian Gulf, surrounded by some of the world's most oil-rich countries. On the other is the Gulf of Oman, already connected to the open sea. The Strait of Hormuz is the narrow passage linking these waters, and from there, it connects to the Indian Ocean and global shipping routes. Picture a massive warehouse packed with millions of products, all relying on a single door to move in and out. The Strait of Hormuz is that door. Except instead of boxes and pallets, what moves through it is energy on an industrial scale. Oil and gas in volumes large enough to shape entire economies. If that door jams, slows, or shuts, the world feels it. And what's most striking is how small this door really is. You can cross from one shore to the other in minutes by plane, yet its impact is measured in stalled factories, blacked-out cities, and billions of dollars at risk. Welcome to Invisible Structures, the channel where we reveal how corridors, tunnels, pipelines, straits, and hidden passages keep the world running, without most people ever noticing. Let me know in the comments, has gas gone up in your city because of this crisis? Drop your city name and the current price per gallon. I want to compare with viewers from other regions. Today, the Strait of Hormuz stops being just a name you occasionally hear in the news and becomes what it truly is, a piece of critical infrastructure as essential to the global energy system as a massive power plant or an entire electrical grid. Hold on to this image, a tiny point on the globe, just a few dozen miles wide, concentrating ships that carried the energy needed to keep entire countries running. Next, you'll see why this water corridor became one of the world's biggest energy choke points, and why so much depends on it. Now that you've located the Strait of Hormuz, it's time to put numbers on this story. Because what turns this water corridor into a global choke point isn't just geography. It's the staggering volume of energy moving through it every single day. On average, about 20 million barrels of oil pass through this strait daily. Picture endless lines of tankers, each carrying hundreds of thousands of barrels, moving through the same corridor day after day, year after year. In just 24 hours, what crosses this point can power entire economies and fuel millions of vehicles, planes, ships, and power plants. If you're enjoying discovering how a single water corridor can shape global energy, take a moment to like the video and subscribe to Invisible Structures. To put it in perspective, think of global oil trade as a flow split into 5 equal parts. Roughly 20% of that total depends directly on the Strait of Hormuz. For every 5 barrels traded internationally, 1 passes through this corridor. It's not a minor detail, it's a massive share of the energy supply that drives the global economy. And it doesn't stop with oil. A significant portion of Qatar's natural gas, one of the world's top exporters, also leaves on ships crossing the Strait of Hormuz. That gas becomes electricity, heat, and industrial energy. It lights homes, powers air conditioning systems, heats houses in harsh winters, runs heavy machinery, and keeps entire cities functioning across continents. In many places, the monthly energy bill quietly depends on this flow through a narrow corridor in the Middle East. Now add some names to the equation. Countries like Saudi Arabia, Iraq, Kuwait, the United Arab Emirates, and Iran use this passage as their main export route for oil and gas. Each, for different economic and political reasons, relies on this outlet to turn underground resources into revenue, contracts, and global influence. In practice, massive energy sources converge into a single funnel. On the other side, insurers, trading firms, banks, and governments track every headline that could threaten this flow, because they know any instability there quickly becomes volatility worldwide. When you put it all together, it's clear why the term Chokepoint comes up so often with the Strait of Hormuz. This isn't just a scenic location or a geographic curiosity, it's a bottleneck. A funnel carrying a critical share of the energy that keeps the world moving. And it's not an open expanse where ships choose their path, but more like a two-lane highway, with strict rules and defined limits. From a distance, just looking at a map, the Strait of Hormuz looks like any stretch of water, a strip between two coastlines. But in reality, it operates far more like a tightly controlled highway than an open space. Ships don't just cross however they can. They follow strict rules, defined routes, and a system designed to prevent disaster. Now imagine zooming in until it becomes an engineering blueprint. Instead of water, think in lanes. There's a designated inbound route for ships coming from the Indian Ocean toward the Persian Gulf, approaching oil and gas ports, and a designated outbound route for loaded ships leaving the Gulf or other continents. Each lane is only a few miles wide. That may sound wide on foot, but for ships over 300 meters long, it's extremely tight. These vessels behave like trucks on a two-way road. There's a fixed direction, minimum distances to maintain, controlled speeds, and constant radio communication with maritime authorities. An oil tanker can't just stop or swerve like a car. Every course change must be planned in advance, because the inertia of such massive weight is enormous. Between inbound and outbound routes lies a separation zone, a kind of invisible median in the water. It isn't used for regular traffic. It exists to increase safety margins and reduce the risk of head-on collisions. Drifting off course, entering the wrong lane, or losing alignment isn't just a maritime violation, it's a direct threat to the entire system. Behind this seemingly simple layout is a layer of international coordination. Navigation rules, communication standards, speed limits, and emergency procedures are defined through agreements and organizations involving multiple countries. Every captain crossing the Strait of Hormuz must follow not just one nation's laws, but a shared framework designed to ensure safety, flow, and predictability. Now add another factor: depth and natural conditions. In many areas, the strait has shallow or challenging sections, further limiting available paths for large vessels. It's not like driving through an empty parking lot where you can improvise your route. It's closer to piloting a plane through crowded airspace, where every deviation affects multiple others. When you combine limited space, massive ships, heavy traffic, and strict rules, the Strait of Hormuz stops being just water between two countries and becomes a two-lane maritime highway, always busy, always critical, and always vulnerable to disruption. And that's where things get delicate. If this highway shuts down, the problem doesn't stay with those in line. Next, you'll see what happens when this corridor locks up, and why the impact spreads across the planet in a matter of hours. After seeing the Strait of Hormuz as a crowded maritime highway, a question emerges, one that keeps governments, companies, and economists on edge. What happens if that highway is shut down? It doesn't take a total closure. Just a few days of disruption, political, military, or even accidental, would be enough to cause serious damage. The impact starts in one place, but spreads quickly. Much of the oil and gas moving through Hormuz is bound for Asian countries that heavily depend on this route. China, Japan, India, and South Korea import massive volumes of energy from the Persian Gulf. A significant share of what keeps their industries running, transport systems moving, and cities functioning comes from ships crossing this strait. If that passage is blocked, even temporarily, the global market goes on alert. Oil prices spike not just because supply is disrupted, but because future risk increases. Financial traders reassess contracts, shipping companies rethink routes, and importing nations scramble for alternatives. The mere fear of shortage is enough to drive prices upward. In past energy choke point crises, the world has seen how quickly market sentiment shifts. Rumors, threats, and isolated incidents can move stock markets, currencies, investment decisions, and public policy within hours. A distant strait, one most people couldn't locate on a map, suddenly becomes the source of rising fuel prices at the local pump. That's the scale of the impact. But it doesn't stop at price charts. More expensive energy ripples through the entire production chain. Industrial sectors are hit as operating costs surge. Some factories cut shifts, others delay investments, and the most vulnerable halt production lines. Airlines reassess routes, cancel flights, and pass higher costs onto tickets. Freight companies raise shipping rates. That cascade reaches everyday consumers. Prices rise not just because oil is more expensive, but because everything tied to transport and energy is affected at once. From food to electronics, clothing to medicine and construction materials, costs climb across the board. In many countries, this means higher inflation, pressure on governments, and emergency measures. At its core, All of this begins at a single point on the map, a narrow corridor of water just a few dozen miles wide, a strait that, when it works, almost no one thinks about, but when it falters, reveals just how much depends on it. Next, you'll see why, despite all the technology, money, and global interest involved, no alternative has matched the Strait of Hormuz at the same scale. Given how sensitive this is, the question is inevitable. If the Strait of Hormuz is such a vulnerable point, why doesn't the world just route around it? The uncomfortable answer is that it can't, at least not in the short or medium term. Dependence can be reduced, risks can be eased, but fully replacing the strait is another matter. One alternative already in use is overland pipelines. Instead of relying solely on ships passing through Hormuz, some countries have built pipelines that carry oil across land to other seas, like the Red Sea or the Mediterranean. This allows part of the output to ship from different ports, bypassing the strait in specific cases. But every pipeline has clear physical limits. Each is designed for a maximum flow capacity that isn't unlimited and is often far below total demand. Compared to the roughly 20 million barrels per day that can pass through Hormuz, even multiple pipelines still fall short. They ease the pressure, but can't match the strait's massive throughput on their own. Another idea is to reroute shipping along longer paths, avoiding sensitive regions. In theory, there's always a longer way around. In practice, that means extra days at sea, higher fuel consumption, more wear on vessels, and fewer trips per ship each year. In a market where freight rates and cost per barrel matter, turning every route into a longer journey is like adding a massive toll to every unit of energy moving around the planet. There's also the issue of time and investment. Building new pipelines, expanding alternative ports, upgrading infrastructure in other corridors, and redesigning global logistics takes years, complex international agreements, and billions of dollars. None of that solves a short-term disruption. Even long-term fixes don't remove the strait's importance. They just redistribute some of the risk. There's also a revealing contradiction. While the world talks about energy transition, renewables, and cutting carbon, the reality is that much of the global system still depends heavily on fossil fuels. That means, for a long time, corridors like the Strait of Hormuz will remain essential. Technology advances, alternatives grow, but existing infrastructure keeps funneling today's energy through it. When you put these pieces together, the picture becomes clear. The Strait of Hormuz is where geography, economics, and politics converge. It sits in just the right or wrong place to concentrate a huge share of global energy flow. Alternatives exist, but none can fully absorb the load this water corridor carries today. In the end, a strip of water just a few dozen miles wide helps power the entire planet. That turns the Strait of Hormuz into more than a headline. It's invisible infrastructure, a critical piece of the system that keeps the world running. If this kind of behind-the-scenes view changes how you see the map, subscribe to Invisible Structures and tell me in the comments what surprised you most about the Strait of Hormuz and where you're watching from. That way, we keep uncovering these hidden corridors that move the world. Chokepoint